Howdy, AP PreCal. It is Ms. Kosh. Today I'm going to look at the part of 1.11 part C with binomial expansion. The way that we like to teach it is we like to put this with the rest of polynomials because it's a polynomial expansion. A binomial is a type of polynomial, and when you expand it, you get another type of, but I digress. Okay, so we are doing this now and not saving it till kind of when it comes in the sequence of things. So notice if I expand anything to the 0 power is just going to be 1. If I take a plus b and I raise it to the first power, I end up with 1a plus 1b. And I'm writing out these coefficients on purpose. And if I expand this, I hope you know that this is 1a squared plus 2ab plus 1b squared. And I know the ones are annoying. They serve a purpose. Hold tight. The next one, if I come along and use my scratch paper from a minute ago, and I take this one, a squared plus 2ab plus b squared, and I multiply it by another a plus b, I can multiply everybody by a, and I get a cubed plus 2a squared b plus ab squared. Now I can multiply everybody by b. I'm going to keep it alphabetical, and I'm going to line up my like terms. So this is a squared b, and then this becomes plus 2ab squared, and then this becomes plus b cubed. What you notice here is I end up getting an a cubed plus 3a squared b. That sounded funny, but okay, I don't know how you would say that. 3ab squared plus b cubed. Okay, so writing that down, this is 1a cubed plus 3a squared b plus 3ab squared plus 1b cubed. Okay, the next one, do you want to see me multiply it? Well, all right. Okay, so I'm going to take this one right here and now multiply by another a plus b. This is no longer equal to what came before, so I don't usually like, sometimes I'll see kids be like, oh, they'll go, oh, 4 plus 3 is equal to 7, and then they'll multiply by 2 and get 14. And I'm like, no, absolutely not. You have made a statement that is false. 4 plus 3 is not equal to 14. Okay, so if you have, this isn't exactly what I see, but it's that sort of idea. If you see 4 plus 3 equals 7, that's great. And then you can tell me 7 times 2 equals 14. This is a true statement, this is a true statement, but that is not a true statement. I just don't like us writing false statements. So that's why I said, pretend all this doesn't happen. I'm just being lazy and don't want to rewrite it. Okay, this gives me a to the fourth plus 3a to the third b plus 3a squared b squared. Notice I'm plus 1a times b to the third. Now let's multiply by b, and I get a cubed b, and I get plus 3a squared b squared plus 3ab cubed plus b to the fourth. When I combine all those, I'm sorry about all the mess, I get a to the fourth, and I have 3 plus 1 more is 4a cubed b plus 6a squared b squared plus 4ab cubed plus b to the fourth. Okay, so what we just did is we got 1a to the fourth plus 4a cubed b plus 6a squared b squared plus 4ab cubed plus, and I'm not just good and I remember it, there is a pattern, so 1b to the fourth. Okay, and so here is what's happening. What is happening? I'm sorry, family wedding over the weekend. If I look at all these coefficients, I can generate what's known as Pascal's triangle. And the next row, so you'll notice what we do is the outside of Pascal's triangle always has a 1, and then I take any two numbers next to each other, add them together, and it gives me the number beneath them. Okay, so the next row we'd have a 1, and then 1 plus 4 is 5, 4 plus 6 is 10, 6 plus 4 is 10, 4 plus 1 is 5, and then we have a 1. And you'll notice too that as we keep going, I should have given myself more space. I'm going to just 1, 1, 1, 1, 2, 1, 1, 3, 3. My triangle doesn't look very triangular. 1, 4, 6, 4, 1. What did we just do? 1, 5, 10, 10, 5, 1. Let's do another row or two. 1, 6, 15. Those two go add to 20. Here's 15. Here's another 6. Here's a 1. Let's do the next row. 1, 7. Add this together, 21. We get 35. We get 35. We get 21. We get 7. We get 1. You'll notice that there's symmetry. So if it's an even number of terms, like 1, 2, 3, 4, 5, 6, 7, 8, there's symmetry right through the middle. So you can come 1, 7, 21, 35. If there's an odd number, then you don't have that middle number repeated. So it's 1, 6, 15, and then there's that 20. If you think of this top row as the 0 row, then what we can do is that the second row has a 2, the third row, so here's a 0 row, this is the first row, second row, third row, fourth row, fifth row, sixth row, seventh row. You think of this as being the 7th row, then it has a 7 in it. And this would be the coefficients if I took an a plus b and I raised it to the 7th, or if I just said x plus 1 and I raised it to the 7th power, we would end up getting x to the 7 plus 7, x to the 6 plus 21, x to the 5th, etc. Okay, that's a little, I'm not quite ready to tell that to you yet. But so now the other thing that's happening is that we look at the degrees of the a and they go down. So it's 4, 3, 2, 1, no a's here, 0. This one, 3, 2, 1, 0. They work their way down. The b values work their way up. So there are 0 b's, then 1 b, 2 b's, 3 b's, and 4 b's. But you'll notice the exponents always add up to whatever this degree is right here. Okay, so if I kept going with this one, well, okay, hang on, let's not do that yet. The other thing, no, let me do number 4, and then I'll come back and tell you more cool things about Pascal's triangle. But I need more scratch paper, because I think the paper this year is not as good. I keep bleeding through as I write on it. Okay, so here, let's do this one. So basically, they want us to expand it out. And they like to do this sort of thing where they tell you what form they want it in. So what we're going to do is we're going to take x plus 3 raised to the 4th power. With 4, we come to that row of Pascal's triangle that has a 4 in it. And so it's 1, 4, 6, 4, 1. Okay, and then we take the x term, or the first term with x, and you can write this all out, and then we start with a degree of 4, 3, 2, 1, 0. And then I take that positive 3, I'm going to do my exponents in a second. I'm separating my terms with a plus sign. And my degree of the b part, the second part, starts at 0 and works its way up. Okay, and so now to expand this, we just clean up all this mess. You may notice what each of this 4 plus 0 is 4, 3 plus 1, 2 plus 2, 1 plus 3, 0 plus 4. Those all add up to 4. And I have my coefficient, I have my a value, and I have my b value, and it shows up everywhere. So this, anything to the 0 power is 1 times 1 is still 1. This becomes x to the 4th. 3 times 4 is 12. This becomes 9 times 6 is 54. This is 37. I lied. 3 cubed is 27. 27 times 4, well, 27 times 2 is 54. Double it again is 108. I was too lazy to go find a calculator. And then 3 to the 4th, 3, and then times 9. And so 9, if you look at, there we go, 9. My ring makes it hard for me to do my fingers correctly. Okay, 9 times 9 is 81. So that's, or 3 to the 4th is 81. That's just a good one to have memorized. And so this is the expanded value. So if they ask us to write it in that form, here we go. Okay, now the cool thing is too that I like to use this example. We are going to take the letters in my name because I have 4 letters in my name and it's fantastic. Okay, we're going to see how many ways can I choose no letters. Well, if I choose none of them, there's just one way. Okay, I have none of them. Done. There's only one way that can happen. How many ways can I choose one letter? Well, I can either choose the K, or I can choose the O, or I can choose the S, or I can choose the H. Okay, and so there are 4 ways that I can choose one letter. Okay, now let's look, how many ways can I choose 2 letters? Well, I can choose, let's write it over here. I can choose K with the O, I can choose K with the S, I can choose K with the H. And then we can also do, what I would argue here is that this is like well, this ultimately becomes a combination, but on this, it's like I'm choosing people to go on a trip. You don't care if you were chosen first or second, you just care that you got to go. So I would argue that KO and OK are the same, like I've chosen those two, even if I choose it the other order, it's still the same choice. And so what do I have? I have OS, I have OH, and I need SH. So there's 1, 2, 3, 4, 5, 6. So there are 6 ways I can choose 2 letters. Now, how many ways can I choose 3 letters? Well, 3 letters is basically leaving out a letter. I can leave out the K, I could leave out the O, I could leave out the S, I could leave out the H. And that gives me, so this was 3 letters. So that gives me 4 ways. And then, okay, the question is, how many ways can I choose 4 letters? Well, there's just 1 way. I can choose all 4 letters. It doesn't matter what order you put them in because it's like, oh, look, everybody gets to go on the trip. Well, fantastic. There's just 1 way that happens. Everybody goes. But have we seen these numbers? 1, 4, 6, 4, 1. What we're doing here is we're doing combinations, and we also just found 1, 4, 6, 4, 1. We just found a row of Pascal's triangle. So the cool thing is that any row of Pascal's triangle can be described as a combination. So sometimes the notation is in CR. Sometimes in IB, we like to do it this way, where it's kind of more like a matrix, and so they'll do n over r like this, and the formula is n factorial over n minus r factorial. What in the world are we talking about? Well, in this, let's do this one. Let's see if we can get 6. So this is saying we have 4 letters, K-O-S-H, and we want to choose 2 of them. Okay, so we could say this is 4, choose 2. This becomes 4 factorial over 4 minus 2 factorial, 2 factorial. Well, what does this mean? Well, a factorial means we're going to start with this value, and we're going to multiply by everything, by all the integers going all the way down to 1. Side note, 0 factorial is defined to be 1, and we'll talk about that in a second. Okay, so this would be like 4 times 3 times 2 times 1 over this right here is 2 factorial, which is 2 times 1. This 2 factorial is 2 times 1. So these cancel with these. A 2 goes into 4 2 times. 2 times 3 is equal to 6. And so my formula gave me exactly what I expected to get right here. Okay, regarding this 0 factorial equals 1, we're doing a lot in this video. This is fun. I hope you enjoy it. I have other videos. Go look through my stuff to see if you would prefer to watch that. If we think 3 factorial, this is equal to 3 times 2 factorial. Okay, right? Because this is 3 factorial is 3 times 2 times 1. 2 factorial is 2 times 1. 2 factorial would be equal to 2 times 1 factorial. 1 factorial would be equal to 1 times 0 factorial. Notice this pattern. Well, 1 factorial is just 1. So this is 1 times 1. And we just need the whole world of math crumbles if 0 factorial isn't equal to 1. I've seen other proofs for that. But I can't think of them right now, and I don't really want us to get bogged down. But, okay, so let's say we are wanting to find the row of Pascal's triangle that has a 1 and then a 15, and then we want 1, 2, 3, we want this term right here. And there's, if it's raised to the 15th power, you'll notice here that when I raise it to the 0 power, I had 1 term. To the 1 power, I had 2 terms. The 2nd power, I had 3 terms. So the 4th power, I had 1, 2, 3, 4, 5 terms. So on this one, this is like, what's the row that has a 15? There's going to be 16 terms. So this first one, I like to, how do I do this usually? I would say this is 15 choose, I just forgot, choose 0 is what I usually do. The reason I slowed down to think, and this would be 15 choose 2, 15 choose 3. I'm using IB notation, but it's a little easier to write. 15 choose 4. The reason I slowed down is because 15 choose 0. Watch this. 15 factorial over 15 minus 0 factorial. 0 factorial. This gives me 15 factorial over 15 factorial times 1. Well, the 15 factorial, this is like 15 times 4 times, they all cancel with this. So this is just going to equal 1. Likewise, if I do 15 factorial over 15 minus 15 factorial times 15 factorial, I'm trying to prove to you, I'm sorry. I'm proving to you that 15 choose 0 is equal to 15 choose 15. And we also talked about there was symmetry. So this becomes 15 factorial over 0 factorial times 15 factorial. The 15 factorials will cancel. The 0 factorial is equal to 1. That's equal to 1 also. Okay, notice these basically switched places. Do you see what I'm looking at when you do the other? Okay, the nice thing is, let's see, I have a calculator here on my desk. If I come into my screen here, I can go options and then come over to probability, and here is NCR and here's factorial. So if I want to do 15 factorial, well, it's going to be a really big number. Really big. Okay, but what I'm trying to find is I want to see, okay, what's 15 choose 1? That should be 15. It is. 15 choose 2. That would be the next term right here. But what we really wanted was 15 choose 4. And this value here is 1365. So if I wanted the coefficient of this 1, 2, 3, 4, 5, the fifth term of this expanded, anyway, it would be 1365. Okay, so, I'm making this rather difficult. Okay, let's see. Let's look at this next one. What is the coefficient of the x squared term? Where, so they have x plus 4 to the fifth. If I expand this and I want to find, okay, this will equal some combination, oh, it doesn't just equal that. I don't want to say that. It equals 6 terms. If I'm looking for the term with an x squared, I'm going to have a combination, 5 choose something, and then I'm going to have a 4 raised to some power. Well, keep in mind, this power here ends up being this, well, I didn't tell you that yet. This is a 3, this would be a 3, these have to add up to 5. And so, in order to find this one, I'm going to do 5 choose 3, 5 choose 3, which is 10, times x squared, times 4 to the third, times 64. So they said, what is the coefficient? The coefficient would be 640. Because the answer is that term is 640x squared, but they said, what is the coefficient? It's just 640. Oh, you couldn't see the directions. There they were. Oh my. Okay. Now let's do this one in that form where they want us to expand it out. This is a good one to, it's raised to the fourth power, so it's 1, 4, 6, 4, 1. 1, 4, 6, 4, 1. We're going to take x and raise it to a power as we work our way down. Can you see that whole thing I'm doing? I think you can. So it's going to go 4, 3, 2, 1, 0. And now this one there, they gave us a negative 5. So I'm going to hang on to the negative 5. It goes to the 0, negative 5. I'm going to just come back and put my exponents up. I need a plus sign to separate the terms. Okay, so we just said that it goes 0, 1, 2, 3, 4. So this just becomes x to the fourth. Here we have a negative 5 times a 4 is a negative 20x to the third. Now we have a positive 25 times 6. If I had 6 quarters, I'd have $1.50 plus 150x squared. This is now negative 125. A negative times a negative times a negative is still negative. Negative 125 times 4, so that's 250, that's 500. So negative, oh, that's a 5. And then we have 5 to the fourth is 625, and it's going to be positive. And there we go. Okay, go check my channel because I have been doing binomial expansion stuff with IB for a lot of years, and I've got some weird problems to practice. I don't think AP will get as complicated as they do for my IB classes, but if you're curious, it's really fun. Okay, good luck. Like, subscribe, comment, go practice, all the things. Good luck to you.